Good morning, all the students. How are you? I hope you all are best and fine. Welcome to our live classes, and we are at our fourth lesson, refraction of light at a plane surfaces. Now we are going to discuss about that. Wait for 2 minutes. Yeah, all the students, and we already completed what is the definition of refraction in the last class. You know very well what is the denser media, what is the rarer media, and how there is a density is affected our refraction. These all the things we are discussed in the last class. Yes, what is the refraction then, all the students? First thing, what is the refraction? Yeah, the refraction means when the light is enter from one medium to the another medium, depending on the nature of medium, the light velocity may changes. Because of that change, light changes its property. Okay, now yes, that property of whatever the nature of light, it is there only called refraction. I hope you understood. There is a when our light is enter from one medium to the another medium, automatically depending on the nature of medium, it may decreases or increases its velocity, may changes the velocity. Because of the change of velocity, automatically the light is varied from its original path. Light is bended from its original path. This is only called a refraction of light. Got it or not? Here, there is a one stick here. When you take here, there is about our rarer media or denser media. So totally based on which principle? Fermat's principle, you know very well. What is the Fermat's principle says for us? Light is always selected which type of path? Light selected the path is whatever the time taken, very low time taken between 2 points. Okay, clear or not all of you? Light always traveled through the which path? Light always traveled through the where there is low time taken. It is the shortest path, that is only. Which one is called the shortest path? Between 2 points which is taken a less time, that is only called the shortest path. You know very well about that. V is equal to what? D by T or S by T. Yes, then when there is a S is the shortest, S is the short one, automatically there is a time taken is also important here. The Fermat principle says for us what? Yes, there is every time the path is chosen by the light ray as to minimize the time to travel. Okay, clear or not all of you? That is only called what actually Fermat's principle here. Every time there is a what, it will be taken, yes, between 2 points in the path which is need the shortest possible to time to cover. Here there is a distance is not a path here. Okay, clear or not all the students? For our life, distance is not a main road period here. Whatever the distances are there here, whatever the distances, you know very well, this is the 2 points. Between the 2 points, there is a one, this is also path, this is also path, this is also path. Okay, wherever you take the paths here, okay, now, but it will be select the what? Select the path. Which path? You don't take it as the shortest path. In case in the shortest path, there is one obstacle is there. That path may not select it now. Yes, don't confuse about this concept here, especially about the Fermat principle. Okay, now, yes, what the Fermat principle has said for us, there is a between 2 points, there is a which path is taken the low time, minimize the time to travel between the 2 points. That path is selected. Yeah, there is in case there is a one. This is a called a displacement in our physical mechanical language. This A and B is there. The A to B, whatever the path is there, it is called what actually? It is called. Yes, which one it is? It is called displacement. Here we not take a displacement path for our traveling the light. In case obstacle is there in the displacement path, that selected that path only. No, it is not like that. It is selected where there is a, okay now, yes, shortest time taken, that path is only selected. Okay now, suppose you take here, in our phenomena, whatever we discussed before that, there is the air, this is the water, this is the normal reality. In case it will be moves in which path, in case there is no property is applied here, refraction property, this path. But there is not like that, now it is selected this path. Why? Because may it is the shortest path, may it is not the shortest, may it is the shortest here. There is a less time it will be taken, this is selected this path only. Yes, may it is taken less time here, it is selected this path only. May it is, I am not taken water, any other media I am taken suppose. Where the less time it is there, that time, that path is only taken here. Okay, clear not all of you, don't confuse, it is the shortest distance. Compulsory it is not taken as the shortest distance. In case there is any obstacle is there, it is not selected that path. Got it? And now that is the first thing you have to take here, concentrate on the time only. The distance may be larger, the distance may be greater here. That is not a problem for us. But the time is important for our life. Which is taken a less time, that is only, yes, you know very well automatically the less time means what? It is a become a shortest path only, but every time you don't go with that one only. If the less time taken to travel between any two points, may it is a become shortest path only. But in the shortest path, there is any obstacles are there. Okay? Yes, that may not selected that path. Don't misconcept on this. Based on this one, I hope you understood there is. Okay, now based on this concept, there is you take about a refraction theory. How there is a refraction is going on inside the rarer media and as well as the denser media. Okay, clear or not all of you? Yes, that is only we are taking. What is the denser media? What is the rarer media? How it is affected the denser and rarer media of our light velocities? That is only we have to go to discuss. There is a what you take it is one of the rarer media and another one you take as it is the denser media. When our light is enter from rarer media to the denser media, you should compulsory what we have to draw here. You should compulsory draw one normal. Where we have to draw the normal every time? Yes, at incident point. All the students, please keep in your mind. It is a very important for your future 10th class purpose also. The normal is drawn at where? Why we drawn the normal? Okay, now. Yes, there is a drawn the normal at incident point of light. Why we draw the normal? Why we draw the normal here? Yeah, you don't go with our light ray. Already we are discussed. Light is a contain high velocity 3 into 10 to the power of 8 meter per second. The normally the reference point for us. Physically, the normally the reference point for us. Okay, now yes, the physically we are not catch the light. Okay, now just where is the what we estimated the light ray may like that it is. The estimation reference is taken from where? The estimation reference is taken from the our normal only. That's why the normal we have drawn at incident point. Okay, clear or not all of you? Yes, there is a what it is incident point. Then next you extend the normal to the other media also. Suppose you take a reflection here. In the reflection also, there is a when you get the reflected ray for us. Yeah, there is a directly or may imagine that our reflected ray. No, it is not possible like that. First you compulsory draw the normal here. You draw the normal here. Yes, there is a what? It is a reflected back like this it is. Yes, when you don't know the normal, automatically know the incident angle. Okay, clear or not all of you? From this incident angle only get the reflected angle. Yes, on which basis you take a reflected angle and incident angle here? There is a base on the normal only. You know very well. What is the reflected angle? What is the incident angle? The incident angle is nothing but the angle between the normal and incident ray. The reflected angle is nothing but angle between the normal and the reflected ray. Okay, now everywhere we are using the normal. Where we draw the normal? We draw the normal at incident point only. Okay, got it or not? Here, there is you take incident point. Here, that incident point. Here, for the refraction, where we are taken incident point? Yeah, where there is a separation of the medias are there. Where we are taken incident plane here. It is also called incident plane. Okay, now where we are taken incident plane? There is a where that is the separation of the media is are there. That is only called the incident plane here. On this incident plane, you take a consent of an incident point here. Got it or not? You take an incident point here. Okay? Yes, and automatically when you take an incident point, that whatever the angle is made with the what actually? The angle is made with the normal and our incident ray is only called what? Incident angle. Got it or not? Incident angle. There is suppose the light velocity somewhat it will be taken as a v1 at where? The v1 at where here? The v1 at our A. The velocity is a become what actually? Velocity of light ray in our rarer media is taken as a v1. when it is enter into the denser media. Suppose there is a no denser media, in case it is a rarer media. Okay, clear or not all of you? Yes, may the light is propagated like this ray or not? May it is appear or not? The dotted lines whatever I am drawn here, may light is move like this. Why? Because the light is contain the property of rectilinear. Okay now? Yes, now the light is moves like this only. No, it is not moves like this light. Okay now? It will be moves in a which one? Yes, because of the density, there is a whatever the particles are there in a denser media. Denser is nothing but like these particles are there. More particles are made than is here. Okay, clear or not all the students? There is a more particles are there here. Because of that, these particles are may disturb our light ray. Okay, now every time there is a what? Disturb the path of our light ray. May it is yes, when it is a touch with this particle, it is a what actually slight reflection. Okay, now disturbed means what? They works as obstacle. Okay, because of that they are ready to go with a slight deflection like this it is. Like this it is. Again it will become. Again like this it is. When you take a total locus of that particular things may become like it is. Got it or not? Yes, whatever the angle now it is made with our yes normal with this deviated ray. That is called what? That is called the deviated ray. That is called what actually? That is only called as what it is? Refracted angle. It is called what it is? Refracted angle. That is indicated as R. Okay now, and one more thing, because of the density of light ray, there is a velocity is become what here? V2. What is the velocity we have taken here? That is only taken as V2 here. Got my point or not it is? That is a V2 here. Here V2 is less than the V1. Okay, clear or not all of you? V2 is less than the V1 in case it is a denser. Okay, got it or not? The velocity is the decreases of our light ray when it is enter from rarer to the our denser. Okay, V2 is greater than V1. Why? Because it is. Why? Because it is. It's take more time to travel the same distance. Okay, got it or not? It is taken less time to travel this distance actually. Okay, it will be taken less time to travel this distance. It will be taken more time to travel in this particular distance. Suppose we want to travel the 2 centimeter in the air. It will be moving with the what velocity? It will be moves with the 3 into 10 to the power of 8 meter per second velocity. But when it is enter into the water, automatically it is not become a 3 into 10 to the power of 8 meter per second. It become compulsory less than that. It is a become less than that it is. Okay, don't go with a high and boy. All the students, there is we are going with a very seriously in our topic. Okay, now if may not it is not interest for you, you require about interest high and boy, you go away from the class. Okay. Who's that? Ayesha Siddiq. Here, there is a what will be going here? There is a what? There is it will be decreases. There is a what? Angle is a decreases means here there is a one thing. Sir, once when you check the triangle property, like a triangle property, it is a become what actually the distance are same. These all the distances are same here. These all the sides are same here. No, it is not same. Got it or not? It is the same. Whatever the distance it is the same here. No, it is not the same now. The diagonal, it is actually diagonal of this rectangular triangle. Okay now, where is the what? There is this diagonal, whatever there, the same diagonal it is. No, it is may not it is. But you don't concentrate, it is a large distance. Here there is a distance is now I am taking here like this. Like this triangle, not the triangle like this here. I hope you got it. Once again, I draw the diagram. Listen carefully. When you understood this fundamental concept, automatically you understood everything. Here it is what actually surface. Whatever the surface we have taken, yes, of water, and this is only called actually whatever the distinguished surface actually here. Okay, now this is the boundary of the surfaces. These are the boundary of the surfaces, and this is taken as incident point. Here it is an incident point. Here I am taking here. This is the what actually incident ray. This is taken incident ray. Okay, got it. This is incident ray, and this is the incident angle. This is taken as A. Okay. Once, what is going on in air? Once take here. In air, there is a what here? There is a less number of molecules are there. There is a less number of molecules are there. And you know very well, these all air particles are contain which nature? Transparent nature. Okay, clear on all of it? These are contain what? Transparent nature. There is this much of molecule may not available in the air. There is a contain of what? Less number of molecule only they contain in the air in this particular place, and they contain the what? Transparent nature. You know very well. It is a transparent nature. Automatically, there is a passes through the air directly like this. Suppose may it is taken in the meters. Suppose may it is taken it is in a meters. Okay. Yes. There is a what actually somewhat 3 into 10 to the power of 8 meters distance is there. Okay, clear or not all of you? The distance from here A to the B is how much? May 3 into 10 to the power of 8 meters we take it. How much time it will be taken for it? It will be taken for it 1 second only. 1 second only. Why? Because the light is traveled with that speed. You know very well. Now come to our denser media. Now come to our denser media. Here in the denser media, there is a what? Number of particles are may become more than there is a whatever the air will be there. Like these particles may arrange inside it. Automatically, there is a disturbance in the getting or not. It is in a non-traffic, it is in a traffic. Already we are discussing. But what is going on? Why it is a come near to the normal? Yeah, there is you know very well. It is a fall on it. What is the reflection in case it will be going? Like this. Though so there is a what? This much of reflection may not possible. May like that, may like that, may like that, it will be coming nearer. Total path is become nearer to it. Clear not all of you? There is a what we are taking here. There is a suppose there is a one particle is there. May it is like this. There is a one more particle is there. May it is like this. It is a reflected ray. It is incident. It is a reflected. May it is a reflection. May it is a reflection. Okay, now, but totally we are not over with the reflection. Now it is a somewhat provided refraction. That mentioned area is refracted here. Okay, there is a refraction that going on for this because of the disturbances whatever there in that because of high number of molecule. So it is not selected this path. The same here 3 into 10 to the power of 8 meters per second. Here in the denser media also. Again you take here what actually? Again you take the distance of 3 into 10 to the power of 8 meter. Okay, got my point or not? Again you take here 3 into 10 to the power of 8 meter here. The rarer media is nothing but which are contain less density. It is called rarer media. Again you take a 3 into 10 to the power of 8 meter here. How much distance? There is this much of distance again. Maybe the travel. We have to go to travel like that. It is possible for our light ray. Yes, when you take a denser media, in a 1 second, it may travel again 3 into 10 to the power of 8 meters per second. Tell me. Yes, I am taking here, there is a what? It is a 3 into 10 to the power of 8 meter distance from where? From A to the B. In case I am taking point C, again it is the distance 3 into 10 to the power of 8 meters. It is a traveled in that 1 second this much of distance. No, it is not traveled when it is a denser. Why? Because there is a disturbances are there or not here. It is a very less number of molecules are there. Okay, now there is a less number of molecules are there. Means what? Morning time traffic like that. When you come to here, there is a what? Evening time traffic like that. At that time, in 1 second, it may not travel what actually as 3 into 10 to the power of 8 meters. At that time, may it is a travel. Okay, now? Yes, not that much of distance. May it is a travel. Yes, this distance only. One check here. Once you draw one line here. Yes, there is a what? In case it is a rarer, it is may travel this much of distance. More distance may travel. One second here, it is a less distance is traveled only. Yes, may it is a travel 2 into 10 to the power of 8 meters only. Got it or not? 2 into 10 to the power of 8 meters only may travel in a 1 second. For the traveling of 3 into 10 to the power of 8 meters, it will be take a more time. Okay, clear or not all of you? That's why only it is a come nearer to the normal. I hope you understood clearly. Okay, it's a very important. These total things are not there in our textbook, but the theme is there. Outer line is a given. Got it or not? Yes? Yeah, may I provide the notes later? Okay, otherwise I have added the notes to our whatever our it is ordered totally IIT components. All I am including IIT components also. In IIT foundation worksheets or otherwise in our worksheets may I am included. It is not possible to take notes on here. Okay, clear or not all of you? You take it is whatever the diagrams I am drawn here. The diagrams you analyze once now. Yes, there is a rarer media. Rarer media is nothing but less number of particles may available in a small place. That whatever the place we are considered. Which one is the rarer? Rarer is nothing but low density. Yes, denser is nothing but high density. All the students, the fundamentals are very important of physics. If you do not know about fundamentals, please raise your question in your chat box. I will provide to you. Why? Because it is 9th class only. Yes, there is no worry about our syllabus. Okay, we have a lot of time up to May. Okay, clear or not all the students? That's why we are going slowly. There is not a problem. Some lessons are also reduced by the government. 4 lessons are reduced by the government. That's why all the students, I am ready to give that all the whatever the doubts are there, whatever the fundamentals are there. Don't be as ashamed. Okay, now yes, it may there is our friends. Now the friends are also not there with you now. Beside of your friends. So many of the students, if you don't know about a fundamental concept, especially. So what members are not know about velocity. May it is not a wrong it is. Okay now. Yes, may not listen at that time. Okay now. May not attend the time of the class. Velocity also somewhat don't know. So many members are not know about the density till now. Okay, why? Because the density is how in our up to whatever the syllabus is there up to 8th class. About the density there is no information is there, clearly not there is information. But only in one thing, where the sink and float. Number 6th class it will be there. Why the bodies are sink, why the bodies are float. At that particular place it will be there. May it is at that time, may you be losses that point, compulsory ask me once. What is the density? What is the density? Tell me. Density is nothing but what? Number of molecules per volume. Number of molecules per volume. Number of molecules per area. Suppose in your class there is a 10 members of boys are there in that 4 benches. Yes, in your class there is a 10 members of boys is there in the 4 benches. The same 4 benches. This side, girls side, 12 members are there. Here we called there is a girls density is greater. The girls are here denser compared with boys. Clear or not all the students? Yes, that is only called density. Means what? In a 4 benches, there is how many members are there? 12 members are there. That's why there is a more number of molecules are there in a same place. When you go for that side, there is only 10 is there. That's why it is called rarer than this particular area. Okay, clear or not all the students? This is only the thing. You know very well already matter around us. In that one we are discussed. Okay, now in the matter around us, the gas molecules are contain a very less number in some particular area or value. When you go for our liquids, there is a more number is there. Because of that more number only, there is a more disturbance is getting for our light ray. Because of our less number of rarer media, molecules are very less in that particular area. That's why there is a no disturbances are there. It's a path are going smoothly, but there is a path are somewhat affected by there is our whatever the molecules are there. Why the velocity is lesser? Simply the statement is not a problem. They written the statement in the page number, whatever in the 51 page number, it will be given at the bottom. If V2 is less than the V1, the medium 2 is said to be denser with respect to the medium 1. Why it is? That is only very important. That is only my explanation here. Why the V2 is become lesser? Why the V2 is become lesser? There is a traffic is there. That's why there is a velocity may decreases along that path. That is only. And in case when you take here, yes, V1 here, V2 is one more statement is also given here. V2 is greater than the V1. The medium 2 said to be. V2 is greater than the medium. Everyone you not take it is a V2, it is V1 it is. Okay, now here there is in this condition V1 is greater than V2. I am taken this is the one type of a situation. Suppose I am taken here the light rays that came from water. The light rays that came from water. It is air. It is air. Okay, clear or not all the students? It is air. Yes, there is a what? Water I am taken here. The light rays that come from. Here I am taken it is a V1. Here I am taken it is a what? It is a V2. This is the incident angle. This is the taken as a refracted angle. Now what is the condition here for the second diagram? What is the condition? There is it is a whatever the velocity it will be taken as V2. Yes, tell me what. Write it in your chart box. Here what I am taking. There is it is a air. It is a water. Okay, at that time taken as V1 is greater than V2. But I am taken here what here? What we are taking here? V2, V1. What is the relation there between V2 and V1? I am taking it there, it is the water. Nobody have idea. The second statement, whatever there in a 51 page, at the bottom it will be there now. That is only. What is that? Yeah, there is a what we have to write here. V2 greater than V1. Depending on the media. Very good. Here V2 greater than V1 we are taken. Depending on the media only we consider the value of velocities. The thing is, we have to know what the thing. In the denser media, compared with the rarer media, velocity is lower. Okay, that is only keeping your mind every time. Okay, now, yes, when velocity is lower, automatically our light ray not travel the same distance as in rarer media. Got it or not all the students? The important statement, when there is a what? Laser velocity is there. You know very well already you discussed it. There is one body is moving with a 40 km per hour. Another body is moving with a 60 km per hour. Okay, who is the first? Who is the fast and who is the first that reaches their place? Who is the content 60 km per hour? Fast means what? In a less time. Already you discussed it, that is in your 7th class. Okay, fast and slow. When you said it is a fast, when you said it is a slow. You know very well there is a running race about the running races. Yes, who is become a first, who is taken a less time for complete one particular race, they become a fast. Here our light ray undergoes the racing. in a what? Rarer media and as well as the denser media. When it is in a race in a denser, it will become, yes, it will become more time. When it is in a rarer, it will be taken less time. So it is a satisfied the Fermat principle or not? Yeah, always light is selected in which path? The less time path. Less time path is only selected here. Okay, based on that one, you conclude about the refraction. Got it or not? Light always try to go in with the what? Less time. Okay, now when the less time, when the velocity is greater, at that time it is the less. Okay, clear or not all of you? Yes, this is only about our concept here. We discussed about a greater velocity and as well as the lesser velocity. Why it is become the velocity is a greater, why the velocity is become lower. Okay, now there is the next one is the ray diagram of refraction. It is a given, yes, in the next concept that is already we have discussed about the whatever the parameters are there here. Okay, now yes, and whatever the value how to recognize it is, and these values are measured by the one value. There is a whatever the bending process is there, that will be totally depending on which one? Nature of substance. Nature of substance only totally. The refraction is depending on totally on the nature of substance where the light ray is passes through it. Okay, suppose you take here, this is the what actually rarer media. I am not taken it is the air or water. It is taken as a what? Denser media. Okay, at that time light rays moves like this. Okay, so come nearer to the normal. Okay, clear? And as well as the same thing I am taken here. It is what actually? It is taken as it is a denser and as well as it is a rarer. Now it will be traveled like this. This is a become incident angle. Okay, now this is a become the what actually? In this one, this is a become the refracted angle. It will be go away from the normal. It will be come towards the normal. Okay, now here it will come towards the normal. It will be what? Go away from the normal. Okay, now why these things are occur? How to measure these things? By using one special quantity that is only called what? Refractive index. What is that? Refractive index. Yes, index means what? Which is a measure, that is only called index. Okay, now the refractive is nothing but which is measure the refractive nature of the rays. That is only called what? Refractive index here. Okay, now mainly you concentrate on where? You concentrate on the velocities here. Okay, suppose you take and it is a V1, it is a V2. Okay, now yes, here we take and it is a V1 and here V2. The condition for here, the V1 is greater than V2. The condition for here, there is a what? Here V1 is greater than V2, and as well as here also we take as a V1 is greater than V2. For our variation purpose, you take it is a V2, it is taken as V1. Yes, here it is become V2 greater than V1. Okay, what main concentration we are concentrated here? The velocities of light ray. The refractive index also. The refractive index also is given the relation between the velocities of light in a vacuum to the velocity of light in a medium. Okay, clear or not all of you? Yes, the refractive index is a what actually? It is indicated with the letter mu. It is indicated with the letter mu. Mu or n. Sometimes it will be taken as n also. N is equal to taken as velocity of light. Velocity of light in a vacuum. Velocity of light in vacuum. 2. Velocity of light in medium. Okay, clear or not all of you? This is only called what? Refractive index. The refractive index is nothing but velocity of light in vacuum to the velocity of light in medium. Okay, clear or not all of you? Suppose there is a once you you take a velocity of air. Okay, now that is about velocity of light in air. That is about 3 into 10 to the power of 8 meter per second only. That may taken it is in a vacuum also. Yes, that is also velocity of light is a 3 into 10 to the power of 8 only. That's why the refractive index is a become what? 1. Okay, now yes, when you take air here, suppose air, how we written it is velocity of light in a A is equal to taken from what? 3 into 10 to the power of 8 meter per second only. Okay, clear or not all the students? And that is in a vacuum also. Vacuum means what? No things are there, no medium is there. At that time also, the light velocity is 3 into 10 to the power of 8 meter per second only. Now, the refractive index n of A, otherwise the mu of A is equal to taken as what? Yes, 3 into 10 to the power of 8 by 3 into 10 to the power of 8 only, based on this formula. Velocity of light in a vacuum, 3 into 10 to the power of 8. Velocity of light in air, 3 into 10 to the power of 8 only. That's why it will become 1. That is given as a 1.003. Sometimes because of impurities of light we take it is 2.9. Okay, at that time may get it is a 0.1.003 may like that it will be. The refractive index is a what? Actually ratio. It not a contain units. Why? Because here velocity of light, that is may taken as meter per second. That is also may taken as meter per second. The both are cancelled with each other. That's why the refractive index is not a contain units. Got it or not? Refractive index. How to measure the refractive index? You have to know the what is the velocity of light in vacuum and as well as what is the velocity of light in medium. When you take a ratios between these two things, automatically you get the refractive indexes. Okay, clear or not all the students? That is only what is the refractive index and how to calculate the refractive index we going by tomorrow. Okay now. Thank you students. Bye, take care. Today your homework is you complete that whatever the refractive index, you write about the definition of refractive index and you analyze the how the velocities are changes in a rarer media and denser media. That is only about our homework and write that all synopsis, the points as a synopsis. Okay, bye, take care.